Bing bong, 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 bing, bing bing bong, bing bong, bing bing, bing bong, bing bong, bing bong, bing. Believe me, folks, it's 8:20. If you want to present your great ideas, come on up, present, give a talk about your great ideas. We're still out of Paris, but believe me, it's great. We're going to save the world with climate change. It's going to be so much. The climate's going to change so much change. Believe me, folks, it's going to be great. You're going to be able to go to the beach any day of the week, outside the Metro Center. Believe me, it's going to be great. Believe me. So if anybody wants to present from any one of the three groups, come on up. Just give a quick, I guess, 2 to 3 minute talk about what your team's analytics approach was, and that'll be that.
Okay.
Fight it out. I don't care.
Yeah, you can talk about the data. All right. We're gonna do the team thing.
Do you need to plug in your?
No,
you're okay?
Yes.
Okay.
Oh, okay.
Need to put the data.
Center.
You have to be here at the center so we can record your idea.
Recorder
over
for the
here.
idea? It has to be over here.
No, over here by the mic, by the microphone.
You can be in front. Okay. Are you connecting to the?
No, it's the.
So yeah, you can stand in front of. Right. Well, this is we're not going to be
here.
Stand here.
Yes, by the mic.
Okay. All right.
Thank you.
So we're looking at global emissions by country, and so what we've done is quickly identify some of the main data sources, and my colleague here has been putting together a Google Doc and getting our names so we can start collecting our data sources. And we've already started to explore the data a bit. But one of the things we're starting to work on is how we will start to put the data together. And made a suggestion that we take a look at the Commerce Department Data Usability Project, which is a very nice set of galleries, not just of neat visualizations, but actual code. And the idea is for our collaboration is to go through some iterations where we use some Jupyter notebooks, where we'll be doing a combination of, we'll start to put together some map visualizations, but also some interactive charts as well. So that's a start. So we have a set of references, URLs for the data sources, and we'll start, or we're already putting some stuff together.
So that's the real science, the brain. The only role I validated or encouraged to use the UNFCCC data, because to me it's the most authoritative and comprehensive. So this UNFCCC will provide the link unfcc.int, and the data is as of 2015. Now I have the lingering thought of maybe there is non-UN emission data that is not kosher or approved by the UN, but that might tell us something. And if I have more time, I would like to go on other type of alternative data set than the UN. But I think as a start, because it's so authoritative, and the role of the UNFCCC, it's the largest international agreement on commitment on reducing emissions in the world, and it's monitored by the UN Secretariat, the UNFCCC Secretariat every single year. It's the agreement that you heard recently, maybe when Donald Trump said he would withdraw. But anyway, so I think that would be a good start. But again, the lingering thought that maybe there are other data sets out there that could tell us another aspect of the story, but they're just not part of the UN data set. Yeah, but that would be the baseline.
Yeah, I think that's a very good direction to go in. But make sure you're keeping track of all the sources you're using.
Yeah.
And
right. Yeah, that's what we were. I mean, the Google Doc is a great start. So he's got our name, so we can share it.
You never know; it could be the next challenge. Your data set can show up as the next challenge.
Oh, Okay. All right. So, any questions? Right. Okay.
Thank you.
Anybody from the second group who wants to present?
So we ended up just looking at the data and brainstorming, and here's what the background of the data is. It was looking at data at global emission change by region, and the thought that they had given out was to look at emission change and see where it might cap out. And so they gave the suggestion of taking bubbles, and bubbles would be going to filling up certain regions, and then if you projected out from 2011 up through 2047, you would see it overfills and we cap out. The data that they had provided didn't extend that far, and so it didn't provide any information on what the policy was. The other piece that they added was the data that was provided was on specifically land use. Looking at land use, it actually provides some interesting data visualizations, because what happens over time with land use is you go from countries that U.S., where it was maybe back in the early 1900s, much more global emissions were from agriculture, shifting to nowadays, let's say South America, where that has a predominance of global emissions. So when we were looking at how to do a data viz on this, brainstorming, one idea would be to use a world map and either use bubbles accumulating into these different regions, or we use one of those, the squeeze maps where it's like the countries or the regions like grow, right, and squeeze, right? So because what's happening is in some areas that, for example, initially the U.S. is growing, right, because it's producing a lot more global emissions, but later that shifts to countries like or regions like South America or Southeast Asia. So using that to demonstrate that. And if you want to extrapolate even further, then you can see these countries growing up to a point where it squeezes out everything. Some of the drawbacks of that is, again, this is only on land use. It doesn't take into effect industry or transportation, right? And it's difficult then to say what the limits are if you're basing it on land use. So kind of keeping in line with the suggestions that was given from the website, it's using this visualization as it develops over time of either accumulating bubbles or area. And definitely from the data, it's looking at the shift from a Western type country to, again, South America, Southeast Asia.
Anybody from group 3? Yeah, you guys have to all do it together. Yeah. What is love? Baby, don't hurt me. Don't hurt me. No more. Do you guys want to?
We could all go.
I'll go at the same time. With glory. So we decided to do the greenhouse gas emissions per country, and we all sort of make maps. So our initial thought was to maybe sort of describe this data through the interface of a map, but we deal with maps on a daily basis, and we're sick of them. And also, like, we're quite aware of the problematic aspects of like using a map to tell stories of data. Sometimes like differences in the geography and the shape of the geometries of the countries can trick your eye sometimes when you're looking at data. So we took a very data-driven approach, and we had like a few dimensions to work with. We had 4 dimensions basically of time. We had greenhouse gas emissions. We had energy use. We had population. And one more, I think I'm missing one.
Energy use?
We have energy use, carbon emissions. At any rate, we thought it'd be interesting to do something like the very famous Gapminder sort of approach. It's really easy, I think, for people to be able to compare the differences between countries, which is often what people, I think, want from these types of visualizations, even more so than like looking at the geometries of the different countries. And I also kind of like the way that the time is displayed through text, because I think for a lot of people it's a bit of a stretch to like put time in a sort of spatial dimension. But yeah, that's the approach that we're going to take. Some problems that we see sort of going forward is there's a lot of gaps in the data. So like, because we don't have a whole lot of time to work on this, we were thinking about maybe just like doing something super basic and probably not very accurate, but like just using like a linear regression to fill in some of the missing spots in the data. Yeah.
Is there a question?
I mean, I'm surprised if, you know, the Gapminder doesn't already have the data set.
They might, yeah. Yeah. It's a good point.
I'm sorry, what is Gapminder?
Gapminder is it's a, I think there's a company maybe.
Hans Rosling
Hans
is the
Rosling's-
most most viewed TED Talk by Hans Rosling.
Yeah.
He was the first one who kind of told stories with data, and so the type of charts you're seeing there, that's something that he gave a really interesting talk on. I would definitely encourage you to check out the TED Talk on that.
So Gapminder is the person that
His company.
I think there might be a
His
company associated with it now, but I just use Gapminder as like shorthand to like make reference because he kind of popularized this particular type of chart.
Right, okay.
Yeah.
And we found like a D3 library for it, so we're just
Oh, okay.
Oh,
Yeah.
that's cool.
implement that.
Yeah.
Were there any interesting findings that you have seen so far?
Oh, we haven't quite. I mean, we've been working on it for a few
We're
minutes.
good or not that good.
Yeah.
Good luck.
Thank you.
Great.
Cheers.
Thank you.
So, group 3, part 2?
I think we'll just ride on one.
You want
I think they cover all our points.
Oh, well,
do you want to get connected?
Yeah, it's here.
Oh.
Do you have a?
I do, but it's.
We have others.
Oh, okay.
I actually started mine on Sunday because this is my first time here. I wasn't sure how far anyone would be at any given point, so I thought I'd come prepared.
Explain.
We were working on, I was with the group doing country emissions. I'll do this real quick.
Is that your laptop?
This is the computer here. Okay. So this is a. This one. Or is mine actually connected now?
Is it?
It doesn't look like it.
Oh, there
Yeah.
it is.
Okay. So this is a bubble map for the carbon emissions by country. And so this is a D3 visualization. Each bubble is a country. If you hover,
being censored.
it is. It's a naughty visualization. There we go. So as you hover over, it shows the country, the amount of carbon or greenhouse gases, in this case it was emitting in that year, population, GDP, and energy use. And you can go through each year and they resize based upon the amount of greenhouse gas. And then you can also filter by country. So if you wanted to follow like China through each year, you could see how much it was emitting in any given year. And I saw that they had explicitly asked for carbon emissions, but if you want to do the sectors like energy or waste, you have to use the total greenhouse gas measurement. So I've added a button where you can switch between just CO2 or just greenhouse gases, and that way you can also filter the type. So this type is just energy, and it takes up the largest amount of all greenhouse gases. But you would be able to like filter through agriculture and waste and urban change, and those bubbles would be a lot smaller than these, and you can kind of see how those filter through. Talking to these guys, we were thinking about the tiers that the Paris Climate Agreement kind of groups countries by, and being able to click on a button and have these bubbles divide into their own categories based on their categorization in the Paris Climate Agreement. And then I think that was the main thing we were talking about, is being able to see where they place in the Paris Climate Agreement. Yeah, that's it.
What do you code this in?
D3. I have this on a page called CodePen, and you can just dump your code there, and people can see it. So if you go to CodePen and type in Jesse Howe, you can find all these and see the source code and download it onto your computer and play with it and add and take whatever you want away from it. Structuring the data is a little funky in this case if you want to do something like this, just based on how D3 works. So I've been having to go through and hand jam it into my own Excel sheet right now. And that's why not everything's on here right now, because that is going to take probably a day just to copy and paste it all in the right positions. So yeah, that is the visualization we're working on.
So with CodePen, you just got to put your own data set.
So I host the actual like CSV file on GitHub. I use gis.github, and then I link that raw link to D3, and then it generates off of that. So it's a little bit of GitHub, and then the rest sits on CodePen.
So you manually configured it with D3, right?
The data itself, so the data so the way I have it set up is that it calls by columns, and each column has a header name. So like when you're hovering over the bubble and you're looking for the name, it's looking for data.id, and which they're all listed. And then if you're trying to resize the bubble, it's looking for the year 1900. That's all in a row. And then all the way up to like greenhouse gas emissions in 1990. That's its own row. Energy in 1990. That's its own row.
So, I'm sorry, but forgive me if I'm wrong, but I thought D3 was just a JavaScript
yeah,
module, code.
Yeah, it codes based off of your data, and your data will sit in some type of form, like a CSV or a TSV or a JSON. It has to exist in some format, and then D3 goes in and you tell it what type of format you're using. So if you're using like a CSV, it knows to look through for the commas, and it structures and organizes the data based off of that, and then you can start to call it in different ways. And then that's how it builds its vector objects. So, yeah.
Anything more, or are we all?
Maybe.
You want to show something?
Yeah, I mean, you know what I'm going to show, like.
Yeah, of course.
It's just an indicator of the countries. It's the same story about the.
Yeah, sure. You want to bring your.
It's online, actually.
Okay, alright.
Can I use it?
Yeah. Sure, yeah.
So I looked at the U.S. states instead of the countries. So just like trying to look at different data. I think it's the same story with the kind of each. It's a time series data tracking different kind of images per country and like. So what I did is I converted that data to Google Sheet. It's the same raw data over here, and create the states and just like separate the states. So what we're actually seeing is I use this platform data visualization kind of approach called Keshev, and imported that data into the software and did some managing of the time series data. And then all the charts are kind of automatically created. So here we see the boring view where there's a listing and you can see different kind of indicators. Let's say commercial and change it across different time and see New York is a time, but then there are a couple of changes. There are a couple of other interesting views. I'm going to reload it because there's also a map view. Yeah. So if you look at the map view, so basically seeing each state as a map. And these are more or less automatically generated. I had to code some of the parts, but the time series data is a little funky to work with. But you can see and change it across different time series or total CO2 emissions from 1990, and the map changes the color depending on the distribution as well. And the nice thing is, for example, if you look at Texas, double click on it and get all the details across these different fields. All of these are automatically generated. I think there's some issue in parsing these two fields, but you can see over, maybe not compare. So one of the things that doesn't do that, other kind of visualizations did really well, and the bowl charts and like comparing different categories and how they change over time. These are more like individual, they're separated. So I think that kind of misses part of that story as a reflection. But you can see all the details over 2011 to 1991. Another view can be the scatter plot. Again, it's kind of standard. You can compare one year to the other, 1990 and total CO2 to a different year and see and even kind of filter to countries that are within this, let's say, window, and go back to the map and see where these states are. And the last view, I'm just going very quickly over like all the kind of the analysis you can do is each state becomes a line. So Texas is the total emissions on the top, and then California, and again I can maybe click on Ohio and see all the details like I did on the other part. And there are a couple of interesting parts where the land use is a little funkier, and kind of you can filter across to see the states in a certain year and how it changed over time. See the ones like Idaho, increase whatever the value means. I think it's, I don't know the context of the data set, but in other case, Wisconsin actually had a different kind of trend, so which is a different trend than I find some of the other indicators. So this is just kind of one way, and the link is over there. And if you have any questions, you can find me later. And thank you.
And Adil is actually presenting more of your work in an upcoming meetup actually for the third quarter. Yeah, we have a third quarter roundup of big data projects, and Adil will be one of the presenters. That will come, I think, next month, if I'm not mistaken, like late October.
I'll be like talking about this and how you create this actually.
Okay, so one more last presenter, and then we'll wrap it up.
Right.
Oh.
Oh, okay. So I basically took I was looking at the carbon emissions again, so for countries and whatnot, and I'm actually using Tableau. So what I did was I took a look at the data set and I noticed that everything was broken out by, sorry, nothing.
Yeah. Let's see. Maybe it's just, yeah, it's just, okay.
So I noticed
push
that,
the button.
yeah, I noticed that everything was broken out by like sectors and subsectors. So I created like a whole dashboard around each of the sectors, and then each of these bubbles corresponds to the size of the emissions for each country. So if you were able to actually select a country, you could see based on the sector that you know where it stood on each of those processes. And then over here, you can go through and kind of go through each of the years. Oops, sorry. And that should apply to all of these. So as you start to kind of push through 2003 and 4, you can see where things kind of start to flow through. So I did this for, oh, and I didn't just do this today. I did this, 2 days ago or something like that. And then actually I even drilled down to the state, so I grabbed the state data and started to push down a little further with the Tableau piece. So I did that for sector and then also by subsector. So again, you can start to look at it that way. And then I was talking to a few people over here, and they had mentioned, you know, trying to build a time series. So if I clear this time series for the entire year, now you can start to see like how an individual country is doing over time, and if it's going up. And it looks like the highest offender in this case is China, but it's also because China's huge. So that was it. I'm sure I'll probably add more stuff to this later. And
So
that's
where is America on that chart?
America, right here.
So we're not the first?
No, we're not the first.
We're first in the top three.
Yeah.
We're like the first number
So who is the first emitter?
The first emitter for agriculture, for the agriculture sector, is China.
China!
Oh, there you go. Second, India. So we could probably even slice it down to like maybe top 10 or something like
Because
that.
you're using totals, right? So
Yes.
if you standardize by population, per capita.
Is that per capita?
It is not per capita.
It is not.
No. But I'll update that.
Yeah. Very nice.
Thanks.
Thank you, everybody. It's very nice presentations. Just one request: if you created something, could you post it on the Meetup too, so everybody could see it? You know, just if you wanted to share it. So, yeah. Thanks
And
again.
in other words, if you have empty cups, trash, or anything else around you, please pick it up and throw it away.
Thank you so much. And see you at Circa if anyone is coming. So I will go.